Welcome to all. This is Eliza. Today we are going to see demo for exercise number 7, pipes. Pipe is a inter-process communication tool. When we create a process, another process resides in the memory. There is no communication between one process to another process. For example, here you see there is a child process. This statement will be executed in child process, and the else part will be executed in parent process. Whatever modification you do in child will not reflect in parent. If you want to transfer some data from one process to another process, we need inter-process communication tool, that is called IPC tool shortly. Okay, now we are going to discuss in this exercise number 7, 8 and 9. We are going to discuss about the inter-process communication tool. The first tool is pipe. What is pipe? Pipe is an inter-process communication tool to transfer data from one process to another process. Actually, we create pipe using this syntax: integer pipe int p of 2. So pipe system call helps us to create a pipe, and the argument is an array of size 2, exactly the array of size 2. Then there will be two locations in this pipe. The location p of 0 or p of 0 represents the file descriptor for reading. P of 0 represents the file descriptor for reading, and p of 1 is the file descriptor for writing. So whatever we write into p of 0, it will write into the pipe. Whatever we write into p of 1 means we are writing into the pipe. Whatever we read from p of 0, we are reading from the pipe. That's the meaning of it. Okay. Usually the standard input device keyboard, the file descriptor is 0. If you read from 0, it represents reading from the keyboard. If you write into the file descriptor 1 is standard output, monitor. If you write something into 1, it means you are writing into the monitor. Okay, that's the meaning of it. Using write statement, you see this write statement. Here we are writing. The syntax is write the file descriptor, the content, and the size of the content. Okay, p of in place of p of 1, if you put simply 1, welcome 8, it will print the message 8 of size 8, the message welcome of size 8 on the monitor. Clear? Write simply 1 comma welcome 8. Write the text welcome onto the monitor. Now what we are doing is, we are writing, instead of writing into the monitor, we write into pipe p of 1. P of 1 means pipe's write descriptor. There are two file descriptor in pipe, p of 1 and p of 2. Sorry, I forgot to write one important statement, that is pipe of p. This function is very important. So after this statement, after this one, you write pipe of p, and then then part is child process, else part is parent process, assume. Okay, in child process, we write the message welcome into the pipe. Okay, now the pipe contains the message welcome. In parent process, we read from the pipe p of 0. Once again, I am sorry, here I mentioned p of 1, but it is p of 0. Please rewrite p of 0. Okay, I'll show the program, then you'll understand clearly. EX7. You see here, I declare one variable integer array of size 2. You please declare an array of exactly 2 for creating the pipe. Here I am creating a pipe of p. Then in child process, just I print a message, while writing to pipe some information. Then what is the meaning of this one? We are writing the text welcome into the pipe right end, and the child exits. When the parent executes, the parent, when enter into the parent, we just print the message we are in parent, and then the parent read the content from the pipe. P of 0 means the read end of the pipe, and store the read value into the array puff. Okay. Now we print the value of puff into the monitor and parent writing. So in child process, we write the message welcome into the pipe's right end, and in parent process we read from the pipe and we write into the monitor. We write into the buffer, that is array, and we display the array on the monitor. Okay, I'll pictorially I'll show you some diagram. So this is the concept of pipe, this is child process, this is pipe, and this is parent process. Okay, the pipe has two ends. One end is called right end, P of 1, always P of 1 represents right end. Another end is called P of 0, that is read end. In right end we can write, in read end from read end we can read. Okay, in right end we cannot read, in read end we cannot write. Okay, so this is the pipe. This pipe is act as a inter-process communication tool between these two processes, child and parent. Now this child writes something into the right end of the pipe. This parent read from the pipe. This is the way the child and parents are communicating among themselves. Okay. Now you come to this program. Child, we create the pipe of P. P is an array of size 2, and the child write the message welcome into the pipe. The parent read from the pipe. So if you want to read from the pipe, we use P of 0. If you want to write into the pipe, we use P of 1. I hope you understand concept very clearly. I'll run this program, GCC Ex7-1.c/a.out. You see the message, we are getting the output clearly. Child writing into the pipe, welcome. The parent read from the pipe, and the message read is welcome. Parent execute. Okay, now come to the second exercise. Before you go on to the second exercise, we learn the function dupe. The dupe function is used to take duplicate file descriptor. For example, if you have file descriptor 1 or a file descriptor, any file descriptor, if you use this function dupe, the dupe function will create a duplicate file descriptor. You can use both the file descriptor for your reading and writing purpose. Okay, now we come to the program. Write a program to implement the following command using pipe and dupe. We are going to implement this pipe concept. So actually this pipe command we can run in our command prompt ls -l pipe wc -l. This is the command we are going to implement. We are not going to this is just command. This is command. This command only we are going to implement with our pipe function and dupe function. Okay, wc -l means what? The wc output of wc -l will be executed by one process. The output of ls -l store in pipe, and wc -l get the input from the pipe and count the number of lines. So ls -l will be executed by one process. wc -l will be executed by another process. The output of ls -l will be stored in the pipe, and wc -l reads the content from the pipe and print the output on the monitor. Okay, once again I'll show you the diagram. So this process, child process, will execute ls -l. The output of ls -l will be stored in pipe. Okay, now parent will execute wc -l. It takes the input from the pipe and compute the number of lines, and the parent will display the output on the monitor. Okay. Okay. Actually, what is ls -l? The name of the files and directories in the present working directory. So how many number of lines, that many number of files are there. So for that we are if you want to find out the number of files and directories in the present working directory, ls minus l pipe wc minus l, if you put, you will 58. There are 58 files and directories in the present working directory. That's the meaning of this. Only we are going to implement. Okay, what is this logic? I'll show you one more diagram to understand this concept. And this is the implementation of ls minus l pipe wc minus l. This is child process. Clear? This is child process. The child process is going to execute ls minus l. This is parent process going to execute wc minus l. Okay. So this child process may get the input from keyboard or some other places. The standard input device is keyboard. Its file descriptor is 0. Okay. The standard output device is monitor. Its file descriptor is 1. So wherever in your program, if you represent 1, it means monitor. If you specify 0, it means keyboard. Okay. So if you don't specify the input source, then automatically the process will wait for the input from the keyboard. If you don't mention any device for output, automatically the process in Linux operating system, in any operating system, the output will be directly transferred to the standard output device, monitor. Okay, that's the meaning of it. Now this is pipe. The pipe has two ends, write end p of 1 and read end p of 0. Okay, what we are going to do is we are going to execute ls minus l and write the output into the pipe. Now the ls minus l output is there in pipe. This parent process reads the content from the pipe, executes and transfer the output into the monitor. The red color line is the process. Okay. In child process, we are going to execute ls minus l using the overlay functions. That is execl function. No, we are going to using that function. We are going to execute ls minus l. Okay. Now, before execute ls minus l, we have to do some adjustments. What are the adjustments? When we execute ls minus l, if monitor is opened, output will be definitely transferred to the monitor. So we have to first close the monitor. Okay. When we close the monitor, this number gets dissolved. This number gets closed. That is, number is 1. Then what we are going to do is we are going to take a duplicate of this right end of pipe p of 1. When we take duplication of any file descriptor, the nearest or the lowest integer file descriptor will be assigned to that file as new file descriptor, duplicate file descriptor. So already 0 is used for keyboard, 1 is not used for monitor because monitor is already closed. So the number 1 will be assigned into the right file descriptor of pipe. So if we close monitor and if we take duplicate file descriptor of p of 1, automatically this child process transfer the output into 1. It means the right end of pipe. Okay. So during that time, we have to close the read end of pipe because there is a possibility to try to read something from the read end child process. We don't want the read end of pipe. So once again I repeat, before execute child process ls minus l command, the child process has to close the monitor, standard output device. First step. Second step, we have to take duplicate file descriptor of right end so that the child will transfer the output into the right end of pipe. Okay. Third step, we have to close the read end of the pipe. So this child process have 1, 2, 3, 4 communications in which only 2 is enough. These 2 will be closed. That is monitor and read end of pipe. I'll show you the program. Then you'll understand little more clear. FIFO Okay. Now you see declaring integer array of size 2, create a pipe, and this is child process. See this child process, there are 3 steps. before, this is the way we are going to execute ls minus l. EXECLP, already we discussed in exercise number 6 how to execute a command in a program. So this is the way we execute a program inside another program. So EXECLP ls is the command. The arguments are ls minus l, character of 0. I don't want to explain much about this command. EXECLP we already discussed clearly in exercise number 6. If you want, you please refer exercise number 6 for more clear about this command EXECL. So we are going to execute EXECLP ls minus l using EXECLP. Okay, before that we did we have to do 3 statements. What are 3 statements? Close monitor. What do you mean by monitor? Close 1. This monitor is closed. Second step, take duplicate of output file descriptor of pipe. So this output right end, the right end we have to take duplicate. Third, this read end we have to close p of 0. Then execute ls minus l. Now from the diagram you tell me what are the operations we have to do in parent before executing wc minus l. So a parent execute wc minus l using EXECLP function. Now from the diagram you explain me. I'll close this page. I'll hide this statements. You tell me clearly what are the things, which descriptor has to be closed, which descriptor has to be open. There are 1, 2, 3, 4 descriptor directly communicate with the parent process. The file descriptor input, the file descriptor monitor, the file descriptor of read end of pipe, write end of pipe. So the parent reads the data from the pipe. So the right end of pipe has to be closed. Before that, first it has to read from the pipe, not from the keyboard. So we have to close the keyboard first, close of 0 first. Second, this right end of pipe is not necessary for parent. The parent has to write the output into the monitor. So what do we have to do? We have to close p of 1 and then one more step. So we are reading from the pipe read end. So after we closing the standard input device, if you take duplicate of p of 0, automatically parent assume that this is read end, the standard read end. This number 0 will be assigned to the read end of the pipe. So 3 step, close standard keyboard close of 0, duplication of p of 0, close of p of 1, then execute. I'll show you the statement here. Close of 0, take duplicate, close p of 1, then execute EXECL. Okay, I'll run the program, you'll understand. Okay, GCC. Okay, before I run the program, once again I'll show you the output. If you use the command ls minus l, wc minus l, the same output 58 we will get from our program ./a.out. You see, same program. This pipe command only we implemented in our program 72.c in 72.c. Yeah. Okay. Now we move on to the next exercise, named pipe. Okay, this one is over. Named pipe, that is MK before FIFO. FIFO is called named pipe because the pipe which discussed earlier will not store in our system. You see, nothing is stored in our system. There is no name for that one. But before is stored in our system. Before we store in the system, that's why it is called a named pipe. This is another inter-process communication tool. Okay, this is also same way. The child process will write into the FIFO instead of pipe. It will write into the FIFO. Okay, so before that we have to create the FIFO. The syntax is MK FIFO, the name of the FIFO, and the flag O underscore create means it will create the FIFO. 0644 means the file permission. So this is statement to create the FIFO, and this is parent process and this is child process. This is parent process. Child process we are going to write into the FIFO. For that, first we open the FIFO. The FIFO name is FIF1. Which one we used in MK before? Use the same name before in read only mode. and we get this open system call returns a file descriptor that is used for writing. So using write system call, we write a text hello of size 6. Okay, now this child process writes the text hello into the write file descriptor of FIFO. Okay, now you see the parent process. The parent process reads the FIFO in read only mode for reading, reads the data from RFD, means read file descriptor written by this function open. So read from read file descriptor of FIFO into the array buff. Now we print the buff into the monitor. Okay, I'll show you the demo for this exercise number 73.c. Here the same thing, we create before, we open the before in write only mode, child process writes the word hello into FIFO, parent process open the FIFO in read only mode for reading, read from the before, and the output gets displayed on the monitor. Okay. So I already, you see, this is before, I remove it, FIF1. I'll once again show you demo. FIFO is removed, GCC EX73.c /a.out. You see, child writing into before, parent reads from the before. What is written by child? The text hello, that is read and displayed on the monitor by parent. Okay, ls minus l. If you see P, the first letter P represents pipe. That is a named pipe. That's the meaning of actually before is called pipe only, named pipe. This will be stored in the name, whereas ordinary pipe will not store in the system. Once the pipe is closed, it will the lifetime or the persistence of pipe is process persistent. Once the process gets terminated, pipe is also gets dissolved. But before is not like that. It is system persistent, kernel persistent, so it will store in the system. So the first letter P represents pipe, ordinary hyphen represents regular pipe, D represents directory. That's the meaning of it. Okay, I hope you understand this concept. With this exercise number 7 gets over, we'll meet once again in exercise number 8. Thank you for watching this video.